which is, I don't know, it's already going by pretty fast. This week we're going to answer any questions, talk about Project 2, kind of go back over regular expressions. Going to kind of cover just a slightly different way than he did it, not better, hopefully not worse or too much worse, but just kind of my way, my take of looking at some of the stuff. And then we'll get through that if we actually we won't get through all of that, I imagine. And then tokens we can kind of start talking about. I know you guys have started doing that in class. Did you guys, he was saying you were going to at least get to longest or whatever, I forget the term, but matching. That's the matching prefix stuff. Longest matching prefix. I was kind of hoping to get to that. I spent a lot of time working on these slides and didn't make it nearly as far as I thought I was going to, but I still have a ton of content. So, any questions at this point? I am going to just go over the basics of the project. Did he cover the basics on the project, or just kind of say, hey, it's available?
He specifically said he'll talk about the recitation.
He did. Well, that's good. Good thing I'm going to talk about it. Perfect. So that's what we talked about at the beginning of the semester. Any questions on the homework or anything related to that? I think that's due Friday. Is that right? Friday? Nothing? Okay. Alright, let's talk about the Project 1 had. Has anybody gone out and actually read what Project 2 is? 2 people. Alright. So, it's got 2 parts. The first part, Adam wrote a program that has a lot of common bugs in it that he's seen students make over the years, mostly with pointer related. So I did it yesterday. He sent it to me yesterday before he posted it, and I did it yesterday morning. It really wasn't that bad. It was a lot easier with CSE or with Eclipse. It would have probably been about as easy. I still would highly suggest that you guys consider installing CSE to look at this stuff in a GUI debugger. It can easily be done in GDB, but it would have been a lot more time consuming for me to do it in GDB. Just the debugging with linked list, you can click on a variable and it will expand the next, and you can see which pointer it's pointing at and actually the address of the pointer. And I mean, it's all right there on the screen, especially like in a 1080p format or something where you get a lot of information on the screen. It's just super useful. But it's up to you guys what you want to do. Let's see what else. So, what he's done with Buggy Program is just inserted several different bugs in there. Some are logic, some are kind of coding related, and there are a ton of different ways to fix them. We're not necessarily concerned about how you fix them, just that they're resolved and that the test cases do pass. So, yeah, wherever you're going to run the program, take Buggy Program and put it in a directory. What I actually did was downloaded it and then copied it to Good Program, and I started editing just Good Program so that I had the Buggy Program to reference back to do the diff and everything. So I'll get to what the diff is in a second, but he's going to have you guys submit patch for this instead of submitting what your code is. So that'll be the output of a program that runs that just calculates what's the difference between the original program and your program, and then gives you that difference. When you upload it to the server, it'll apply that patch to the code, and then run it to see if you pass all the test cases. So if you get into the server, you can download the buggyprogram.c and the test cases tar, and put them in the same directory. Use the untar command to extract all the stuff, or the tar command to extract everything. And that'll put the test cases in a directory. The script is similar to the one we talked about last week. It's they use .txt instead of .imp like I did, but it's going to look in the folder, look in the test cases folder and run all the test cases that are in there. And those are specific ones. The specific ones that you'll need to pass when it's fixed on the server. So yeah, you can compile it using GCC, and then you can run the test.sh. Test.sh probably won't have the permissions that you need to run, so does anybody remember what command you use to change permissions in Linux? Yeah. And what flag would you add to get it to run? Do you remember? It's okay. Anybody? What's that? Plus X. Exactly. So chmod plus X, and then the name of the file will give it execute permission so that you can just type it at the command line / test.sh. So when you do get done with it, he's got in the document, you're gonna, as I was saying, you're gonna submit the patch. The question is, what is a patch? So using this diff command, you take the buggy program as input, which is unchanged from what you downloaded, the good program, and then fixbugs.patch. The fixbugs will have we don't have an example of it, but it will have just lines in there that are highlighting the differences between the two files. What's the same and what's different. And then you submit the patch. And it is very advantageous to use any kind of debugger. For this one in particular, the C-line GUI one will be more than adequate. GDB is really powerful, but if you haven't used it before, there is a little bit of a learning curve with it, but there's tons of stuff on the internet to figure out how to use it. All right, so what buggy program is supposed to do is it looks at a text file, reads in the values from, doesn't look at a text file. It takes input into standard in, and then loads all the values from standard in that come from a file that you're redirecting when you run it. I don't think he has an example, but you redirect with the less than sign, so you'll a.out after you compile it with the less than sign, and then the text file that you want to serve as input, and that simulates your input via the keyboard. The point of the programmer, what it does is it takes in two things. It takes in I'm not going to remember. Let's a little bit complicated. seeing right here the difference between something that's text file that's created on Linux to run on Linux versus on Windows not handling it quite right. Fortunately, Notepad++ understands the characters correctly. So this is the input of the file. So this is the complicated test. It's got names and numbers. So what it's supposed to do is sort. It's going to take this list, load it into a linked list, and then sort it, and then print back out the output in the sort order as designed. The ties should go to the next one, to the next. Ties should go to the number field and use the number field. So we can look at the expected output from it and kind of get the same. So this is what the output is expected to look like. It's in alphabetical order, but then we get to Wesley down here, and you can see that it's actually ordered by the numbers. So that's what it's expecting it to do. I can tell you that the output's not going to look like that. So there will be, like I said, some logic issues with that. In the program that you guys will have to look at the test case and look at the expected output to kind of figure out what the program's going to do. That kind of serves your requirements. Okay, onto the Lexer API. This one is you're going to use the functions that they provide in Lexer.h and Lexer.c and incorporate them so that you can read in tokens and then determine if what the token type is, and then you're going to put those together and print them out. So in the instructions, there are just some basic considerations. So this up here, all of this text is talking about how the functions that you're going to use work, the get token and the unget token. I don't think you actually will need the unget token for this one. And then the Lexer.h defines, as you guys can probably read, the global variables that when you do the get token, it's going to set these variables so that you can access them. So the T-type is an enum that's going to be a enumerated type that's going to be one of these types up here. Kind of understanding how this works is helpful because you will be using this. This will build, your code won't build. You'll have all new code for each assignment, and they'll add more code to it, but the basics of the get token and the unget token you'll be using for the rest of the semester for getting your tokens into the program. And then, so you've got T-type, you've got current token, so it's stored in there, and it tells you based on the type, there may be different values in there. So, so it's got a empty string if it's not one of those types. So if the token type is of any one of those, then current token's populated, but for the other ones, it's an empty string. The length of the string stored in current token, and then the line number. So with this one, what we're wanting to do, what we want to focus on is just ID and num. So in a file, it'll identify those types, and then we just want those to be loaded into a linked list as a node of a linked list and stored about each one. The token type will be one of the values in the linked list, and then the current token and the line. And you will actually, conceptually, you may not use this data structure again, because on future assignments you can use the ones built by the languages already built by somebody else, which are just easier to use, and you aren't restricted to just linked lists. You can use hash tables and all sorts of other things that are built in, which make actually coding it a little bit easier with the data structures. But for this one, you have to use a linked list. You have to create your own linked list.
So you can just build a list function for this one?
No, and it's C or C++. Yeah, C or C++. But let me make sure I'm not lying to you.
That is what it said.
Okay. I can't remember where I read it, but I remember that from ours too. But yeah, you gotta build your own linked list. The purpose is just to make sure part of what you'll be graded on is whether you're freeing the memory appropriately, whether you're doing everything, all the little detailed stuff that is really hard to get right. This was the one program that I lost credit on. I did this for I don't remember what I did, but I did something. I didn't do something right with the memory. And it's not that it's hard, it's just kind of detail oriented, making sure when you allocate that you deallocate, that you free it. The C++ makes that a lot easier. We were not allowed to use C++ when we did it in ours, which is part of the issue too. It's been like 20 years since I looked at C or C++. Yeah, so you'll read in the tokens. They're in kind of this pseudo format. You'll output the tokens into this kind of format. So I don't know. I think this is easier from an example, which is what I looked at. So these instructions are if you're using C++ and you're going to do it all from the command line, or use Emacs or something. That's fine. So here is an example input. So here's what the text file would look like that you're inputting in. So it's got new lines at the end. It's just kind of all sorts of random stuff. What's highlighted here, these things, those are all these are all IDs. So those are all variable names, basically. They're not a reserved word like while or if, and so that's what you're going to pull back along with numbers. And then you will order it in reverse based on line number. And then in reverse.
So how exactly would you get the line numbers from the text input?
How do you what?
How would you be able to tell the line numbers from the text input like that?
So the text input will come from get token, and the get token will load these global variables for you with all these values. So it'll populate the line number value, the line.
Okay.
So each token that you get, you'll say get token, and then all these globals will be set. You can do whatever you want with them.
Okay, then so you can just set the line number in that linked list then in that case.
Yeah. Just from the integer value that's in line.
I got you. Thank you.
Yeah. So, and then the output is in reverse. The only thing that I'm trying to remember. Notice the tokens are listed from last to first in reverse order. And so we see CSE and 1, 2, 3 are both on line 1, and the reverse order so that CSE, this is the very last one encountered. So it's the last one on the list, where 1, 2, 3, even though it's on the last line, is still second to last. So it's going up in a kind of snaking order. Any other questions? Good. All right. If you think of something, feel free to email me. Be happy to answer it. I will have played with the program probably by tomorrow and reminded myself of all the little tidbits with it. All right. So regular expressions, you guys have been covering these for like a week now. Conceptually, I break them up. I think they're broken up into really 4 different parts that we kind of cover. We start with the valid syntax, move into definition of languages, and then move into, okay, is this string in the language? And then regular expression versus map. I think it's helpful to not get confused with what each of these are, because they're kind of conceptually different, but they all blend together going through the process of trying to conceptualize and figure out all this stuff. So valid syntax for regular expressions from about a week ago. A regular expression will follow, that's syntactically valid, will follow one of these formats. So just like you've been doing in class with the problems, with a regular expression, you need to be able to apply one of these rules, and with the homework, you need to be able to apply one of these rules. So, for example, given given that sigma or alphabet are the following regular expressions, are those valid regular expressions?
For V,
There's a super picky one that's not valid.
I was going to say for V, is that the dot operator, or is that just like...
Yes, that's the dot.
Also, X, C, oh, I see, X dot, C dot, Y dot.
Yes. Which one's the most, the most complicated one on there has a bug in it.
X.
Are we saying a dot is required for concatenation?
A dot, yeah, good point. A dot is required for this notation,
So
although
the
we
name
will
of
move away from it. Conceptually, right now, it's important.
So the end of W is invalid.
Yeah, that's exactly right. W is sneakily missing the dot right here. See between the difference between the two? So, yeah. Sneaky. So we use regular expressions to define languages, but let's kind of start with, so what is sigma? What is it? We kind of saw it on the last example, but what is sigma? Yeah, it's the basis for everything in the regular expression that we're going to use regular expressions for. So then, if it's the alphabet, what is sigma star?
0 or more characters from that alphabet.
Yeah, so it's the entire set. It's all possible combinations of those letters in every weird, wild way possible that anybody could ever imagine, going on and on and on to infinity. So, given the sigma that we had on the last slide, is that guy in sigma star.
Yes.
Yeah. So, I mean, it can be anything. It can be as long as you want, or, as big. But this is sigma star. This is the whole huge thing that we've got. What we use regular expressions for is to turn it into a language. So what is a language?
Set of strings.
Sure. Set of strings that we kind of identify. But it's also a subset of sigma star. It's even if we came up with a language or a regular expression that matched everything in sigma star, it's still a subset of sigma star. So what we're trying to do is describe that subset. How do we do that? How do we describe the subset of sigma star that for the things that we want to have in? Say again? Yeah, exactly. So we use regular expressions to define that subset. I know this is kind of repeating stuff and you guys have had homework on it, but now that you've done that, hopefully at least started on it, this is kind of taking a step back and going back through this stuff to kind of reiterate the importance of it and where it kind of all fits together. So if we define a language using different rules, different regular expressions, we can come up with different sets that they describe. So for example, given the values that we have on here, what is the language of V? What are the values that are when we evaluate V? Not all of them, because we can't do all of them because we have some stars that are some of the stuff. But what would be an example of a string that is defined by that's in this set?
Is X a regular number, regular expression here? X.
Yeah, so X is defined by the X above. So
Is epsilon belongs to the alphabet?
what's that? Yeah.
X can be epsilon, right?
Yes. So X can be Z, which is the A, B, or C, or it can be epsilon.
But epsilon is not in the alphabet.
We're going to talk. Explain that now or later. So we're going to talk about that in a minute. I've got some examples kind of talking about epsilon and that confusion. Epsilon is a valid regular expression. If we go back, so these are all regular expressions in here. So all of these are valid regular expressions. And as valid regular expressions, all they have to do is meet our rules. So rule number 2 is that a valid regular expression can have epsilon in it. It doesn't have to be in the alphabet, because a valid regular expression is the epsilon character. The epsilon acts just like the or just like the star or the dot. It's an operator kind of. It's a string that's included in the regular expressions syntactically. So it's syntactically valid. Is that helping some, or does that make it even muddier? Do you understand why the epsilon's valid there? Okay. So what might be an example of a string that? Go for it.
A. Because everything except Z can go to epsilon.
Yeah, exactly.
Just put Z.
Yeah, because you can use epsilon around each of them and go to A. I think so. Hopefully that's visible. I kept the rules on the right hand side. Yeah, so this is using, as I just kind of restating it, this is using V to constrain sigma star down to the things that we want to include. So some other examples, A1A, 234, A34. So if we look over here, we can match up the first A using, we'd have to use Y. So X here can be sigma, so it can be nothing. We concatenate empty string with Y. Oops. it's different. I changed it between slides. I had it going one way, and then I got to an example that I wanted to use with it a different way. All right. All right. A is in X because it can be epsilon, so we take the A from there. Then Y is got the 1, and then we've got Z here, which is the added A, and then the W will take care of nothing because, oh no it does, the 2, 3, 4 is in W. We could have one or more 4s because the star is tied to the 4, and then the X will handle the A, and then the Y handles the 3. So what about, well, we just went. So that guy is in there. Question? Or just,
Well, no, I was just because. So W is 2.3.4 star, which
Right.
means that if you're going to invoke W and it doesn't go to epsilon, it has to have a 2 and a 3,
Right.
and then 0 or more 4.
Right.
Okay. So I thought, I was like, does that star need to be on the outside?
well, it could be, but yeah, but it's 2, 3, 4, 4, 4, 4, 4, or 2, 3, or it covers those scenarios.
So if it was on the outside,
Right.
what would that like substring look like? Would it just be like 2, 3, 4 repeating? Like
Yeah,
0,
yeah, it would have to be 2. It would have to be that whole thing repeating, the 2, 3, 4 repeating. All right, so I think we already answered this one. That is A. Oh, I'm sorry.
Oh, she's right.
Good catch. Nice. Yeah. That's what I was. That's how. Hold on. See, I was going to talk about epsilon. See, it's 20 eyes versus 1. Now you guys can see all the answers quick. Now it's in the alphabet. Sorry about that. It was supposed to be in the alphabet. That wasn't supposed to be. This is supposed to be, kind of like your truth. Like there aren't supposed to be any errors in it. So that was totally my mistake. I really tried to catch errors, but stuff's really complicated. All right. B123 is it part of the LV? So you start down here. Hope my answers are right. I'm only checking once. Anybody? No? Why not?
Because you get from X you get B, from Y you get 1 to 3, and then you have Z. So you have to get A, B, or C.
An X and empty?
Yeah, or
Yeah.
no, I think it's.
And then Y? Do we need a Y? Does Y not have value for the empty? The star, what is? Does that make sense? Okay. And then we get to Z, and once we get to Z, all we need to do is pick up the Y on the end. Because the W can be epsilon, and the X can be epsilon. Question? Comment? Good? So yeah, B123 is good. What about this monster?
So before that was good. Basically, the last two, the left X and Y at the very end.
Yeah. So the X is going to go to epsilon again on the B123, and we're going to use this Y for the 1, 2, 3 because it's star. We take 1, and then 2, and then 3. But good questions. I'd much rather you guys ask questions. I hate standing up here just blah blah blah. So
No. Say no.
no, no is right. Why?
Because if you open with X, X goes to Z, Z goes to A, then you have Y. Y can't put B in there. You can't get B before you get 1, 2, 3.
Correct.
Why
Well, you could. You could skip Y.
Oh, well, yeah, but then you have to put in 2, 1, 2, 3s though. The only thing I can do that is Y.
Exactly.
So
Yeah. It's either one or it's one or the other. So does that follow? Do people follow that? Does everybody follow that or no? See a couple friendly faces. So let's dig into that some more. So A we can tie to X through Z can go to A, and then we've got this B that we have to take care of. But here's Y. So Y can be empty string, but Y definitely can't be B. So we would have to make Y an empty string to keep going. And then we get to Z. Z can easily take care of the B for us. That's great. We get to W. 1, 2, 3 does not fit in W, so we have to go to this empty string. And then we go to X. X can effectively either be blank or have letters, so that doesn't work. And then we get to this Y. We're still over here on this 1, 2, 3, and we're on the last one. Yes, it fits the 1, 2, 3, but there's no A here to satisfy the Y, or after the Y. So that's why this one's not in there. What about this guy? Well, I may have made a mistake. I need to turn on presenter mode so I can see the slides before they go up there. See my animation. Yeah, based on what we said on the last one, it should not be in there, but I'm almost positive I put a check mark. So it's following the same pattern as this one. If we failed at the A before, then it would fail at this C on this one. Oh, I got it right. That was good.
Would it actually fail on the W though? Oh no, because it failed at the A, right?
well, it failed the same area.
Yeah, it failed at the A here. We failed here. And it failed at the C here. I mean, it's matching the same value. It's these two characters that push us back that first Y, so we can't do two numbers, which is what the gentleman in the back said earlier. What about this guy? Bunch of numbers. I got this one.
Yeah, that's it.
How is it?
So X goes to Z goes to A, and then Y, you just have a 1. And then Z goes to Epsilon. Or no, I'm sorry. Wait. I ruined everything.
No, I mean, it is valid.
Z's empty, the W, you can have 2, 3, 4, 4.
Well, X and Y. Well, Z will probably be in.
No.
So
Yeah.
Epsilon and Z, you get
Yeah.
to the.
This is unintentionally broken.
Okay.
But you're right. Yeah, A would have to go. I mean, A has to go with X, and you have to have this Y again. It's pretty similar to this problem. You have to have this Y again so that you can get the 1 out of the way, because we have no 1 in the 2, 3, 4. So Y would have to fire off at least the 1, and then we get to 2, 3, 4. But we have Z here, which needs a character, and that's what breaks it. And then we'll just disregard that this says check for a second. It's not correct. It's not right. I'll mark it off in a second. I just want to get to the last one without giving it away. So, what about this guy?
Wait, no.
What's that?
There's no way to get B.
Yeah.
No, that's it.
Yeah, I forgot to put this in here. I did it this morning, and I forgot to put this in here. I started on last night, and then was up by about 5 this morning. So, yeah. So why? Can you say why?
There's no way to get D.
Yeah, there's no way to get D. D is in sigma,
Oh, that's right. Oh.
right? Yeah, this was meant to be a little tricky, but D is in sigma. But there's no rule saying we can get to D, so it doesn't matter because it's in sigma. Totally a trick that Adam would use on a test or a homework problem. So always good to be watching out for. And we talked about why it's so. All right, if I don't do this now, it might not go away. All right. The only drawback to animations. So what must the language defined by the regular expression be? What does it always have to have here based on these rules? Z? Exactly. Yeah, it has to have a value that's in Z, A, B, or C. There always has to be an A, B, or C in any of these, so you couldn't have pure numbers. That's good. Exactly what you said. Did you read the slide? So, is this a valid set? Is this a valid epsilon? Is this a valid set of alphabet characters?
Are those the boring dot just characters? And
No,
not
just
operators? Then yeah, sure, why not?
Yeah, we could do this. It's confusing as all get out.
Right.
But we could totally do this. We could define something like, we can put any kind of character we want in epsilon. It could be a foreign character. It could be a special dot or whatever. It's our character set. You know, it's what we're going to work with. So the question is this a valid regular expression? And this is not actually easy to answer because it's maybe. We don't know we could take and say, okay, we're applying the EE from the alphabet, and yeah, it's valid. But we don't know what it actually means, right? It could mean that these are both empty strings on the end concatenated together. It could mean, which one is actually being worked. So you'll see that we define it like this, and I know Adam's done this on a few of his slides already, and the point was just to kind of point this out. If we have an epsilon in an alphabet, then we probably want to escape it. Although it's a programming thing, it's just kind of a sign to us to let us know it's not an operator in the regular expression language. It's just a character. It's just something special, a special character that we got to work with. Because you guys will have stuff where the period is, you use that for tokens when you're defining decimal numbers, for example. So we do have the appearance of things that look like operators, but as characters. And you could do it with epsilon if you want. So the question is this a valid regular expression? Yes. All right. See this? And this is when you would see epsilon in an actual string. If epsilon is not in your alphabet, you won't see epsilon in a string. I'm not lying, am I? That's not.
You shouldn't see epsilon in a string. It doesn't add anything to a string.
You won't see epsilon in a string, but you will see it as a standalone character in a set. So in a set of strings, epsilon is still there, but you won't see it as like this, for example, in a string, unless it's some kind of special character.
Is dot A same as epsilon dot A?
Say that again. Is dot
A the same as epsilon dot A?
Yes. Yes. So A would be the same as epsilon dot A. Is that what you're saying?
No.
No.
Dot A.
Dot A? No. And so you would need that's a regular expression. You would need epsilon or some kind of character before the dot to the A. Does that make sense? Epsilon becomes an empty string at the point that we're evaluating whether something is in the language. So when it's a regular expression, it's just like it's a function. It's just an operator. So it's something we say in our heads. Is there a chance there could be an empty string here? If we go back and look at the rules that I had here, where I had empty strings. So these, we were for x, we could have something from z, but we could also have the epsilon there. But when we're making the expression, when we're making some kind of expression, we would have the epsilon. So an example might be we could totally, this would be fine. What comes before v? U is terrible. We'll use t. We could do that, and we could do that for sure. So that's like a placeholder, and it's saying concat it with an empty string, which means that what values in this set? What values, if we did L of t equals, what's in that set? Yeah, exactly. That's it. So when we're at evaluation time, that's what we're looking for. We're looking for the AB. The epsilon's like a placeholder, because you'll have spots, and this will make more sense as we move forward why we have it. But you'll have spots where it's like, well, it could be no space or it could be a space, and those rules the epsilon kind of holds that spot for us, so we can still evaluate it. But you won't actually see epsilon in between these two. You won't see an epsilon there. Does that help? Cool. All right. So imagine that we have A, B, C, D in a set. Is this a valid regular expression? What does L of Z look like? So what's in the language? What is
Either ABC, ABC, or ABC, BC.
exactly? So did I get it right? Yeah. So the language is going to have ABC, ABC, and then optionally have the other A or an empty string. And so these are the things that we would find to be matched when we're given a string. So when we're given a string and asked if it's in the language, we would say, is it in when, we're not doing it this way, but this is effectively what you're doing. You're saying, is it in the set? You're checking to see if it's in the set. So yeah, that one is in, and that one is not in. Sorry. See, I'm going to have to turn on presentation mode now, but I'm using animation. Yeah, so going back to the point about epsilon, which is kind of these slides, this is not in the set because it's an actual epsilon character here. It's not an operator anymore.
Okay.
Does that make sense?
I see. So basically, the epsilon is the empty string, which like the character epsilon.
When it appears in a string, it's the character epsilon. When it appears in a regular expression, when it's up here, it's the operator for regular expressions.
I'm a bit confused. Sorry.
No, it's all good. It's totally good.
It's a confusing thing.
It is confusing, and that's why I was trying to come up with some example. This in particular to make you a little more confused, but also to help clarify in the same once we get through it. So ask. So do you know why it's confusing, or what the whole point of recitation?
The thing I'm confused about is that it's empty, so it's not empty in that regular a string, but not a regular expression. So in a regular expression, it's not empty, but if it's in a string, it is.
Or reverse it.
Reverse. Yeah, the opposite. If it's in a regular expression, it's the empty string.
Yeah.
If it's in a string, if it just shows up in a string. So look up here. You see that this is a regular expression. This is the operator empty string. These are all the things that are possible in our sigma, right?
Oh, I see. So in that instance, an ABC, BC would be the right one, but because the epsilon in that It's the character of epsilon that's not.
Right.
Okay.
Yeah.
So,
So this is not, this epsilon here is bad. It's not in our set, it's not in any of our characters, and this is not a regular expression, it's a string. It's what we're seeing if the regular expression describes.
okay, I got you.
Cool.
That's where I was getting mixed up.
No, it's all good. I mean, it's, Adam and I told him I was going to do this and try to confuse you guys, but also try to come through the confusion a little bit. All right, so we're at time. It's 50 minutes. I spent a lot of time on the project. I hope I helped a little bit. I wish I'd re-looked at that this morning. I looked at it yesterday. I was like, oh, that'll be fine. Anyways, if you have questions, I've got normal office hours. We are likely discontinuing the Monday morning. For some odd reason, students don't want to show up at 8:30 in the morning on Mondays.
You'll wonder why.
Can't fathom why. I wake up at pretty much the same time every morning, so when you get old, that happens. Anyways, so we're discontinuing. So don't suddenly decide to show up at the Monday morning one expecting there to be one. It's likely it's going to be canceled. We're working on it right now. But just in case.
Labor Day anyways, right?
Oh, it is Labor Day, guys. Thanks, guys.
Are these slides provided?
Yeah, actually, give me one sec.